Ready? Here's a summary. A is just the horse, B is horse and cart, C is horse and sled. Here's a free body diagram for case A. The only unbalanced force is the force F. So the horse is accelerated only by the F. That traction, the frictional force. Here's a free body diagram for the horse in case B, and a separate free body diagram for the cart with red forces. So because there are two objects within this system, we have to have two free body diagrams for the system. This is an example of Newton's second law, having a free body diagram. Newton, or an unbalanced force in a free body diagram anyway. Having a second object with Ft, Ft, that is an example of Newton's third law. Aha! Two tension forces are an action-reaction pair, so if the horse is being pulled left and the cart is being pulled by the right by equal forces, neither the horse nor the cart can move. Makes sense, right? No. You're right, the tension forces are an action-reaction pair and are in equal strength and opposite direction, but those two forces act on different objects, so they can't cancel. They can't cancel. Only things within the same free body diagram can cancel. Newton's second law applies to the horse and the cart separately. The horse accelerates right because its rightward force F is greater than the leftward force Ft. The cart accelerates to the right because its rightward force Ft has no leftward force to balance it. Two Ft forces are an action-reaction pair and are equal newtons in opposite directions, but they don't cancel because forces can only cancel when they are applied to the same object. Here's a free body for the last case, C, and a separate free body diagram for the sled. Newton's second law applies to the horse and the sled separately. So we have the horse accelerating right because its rightward force F is greater than the leftward force Ft. Right, we can see that. The sled accelerates to the right because Ft is greater than Ff. Ft forces are an action-reaction pair and are equal newtons in opposite directions, but they don't cancel because forces can only cancel when they are applied to the same object. That's it. Told you it'd be quick.